Today, we're going to talk about gravity, the force of attraction between two objects of mass dependent on the distance between
Yeah. You see, magic. Got it.
them. No, not magic, physics. Here, I'll explain. So here we have the Earth and the Sun. That's what I just said. They each have their own mass and the distance between them, we'll call r. We know from Newton's laws that forces come in equal and opposite pairs. So the force of gravity the Earth feels from the Sun also feels from the Earth. Here we have the equation for the gravitational force and some information about the values. Here we have the Earth and the Sun. If we plug those numbers in, we find that the total force on the Earth by the Sun is that, or 8 times 10 to the 21 pounds, which is gigantic. We know from before that the weight of gravity looks something like this. But this looks different than what we learned about before. So what is this little g?
I'm not sure. I'm afraid we need to use math.
That's quite alright. Here. So first we need to define r, which is the radius of the Earth, and h, which is the height above that we're standing. Then we know that the total height that we're standing at is the addition of these two. But we know that the radius of the Earth is much greater than the height that we're standing. So, when we plug that into our gravitational force equation, we find that the height that we're standing really doesn't matter, and it approximates back to this. Because this isn't changing very much with our height, we can plug in the radius and the mass of the Earth and get 9.8 meters per second squared, which, if we remember, is the value of our little g. Surprise, surprise. And this means that when we're on the Earth, it doesn't matter whether you're standing on a mountain, or on some low hills, or at sea level. The value of g, the acceleration due to gravitation, is always about the same.